Good day, students. Welcome to Mathgotserved.com, and this clip we're going to be going over how to multiply radicals. This standard is covered in Algebra 1, 2, and Pre-Calculus courses. And don't forget there are 5 practice problems at the end of this presentation that we'd like you to do in order to demonstrate mastery of the content covered. To gain access to our entire playlist and other valuable resources, take a look at the links in the description below or just visit our website at Mathgotserved.com. Alright, before we get started, let's take a look at the formula that's going to guide our problem solving process, okay? So we're looking at the formula for multiplying radicals. Alright, so the formula that we're going to be using is as follows. If we have a coefficient a of the square root of x, be multiplied by the coefficient b times the square root of y. Now, how do you multiply a situation like this? Well, what you do here is you multiply the coefficients. So a and b gets multiplied with each other. Okay, so you have a times b. And then you have times the square root of, and then you multiply the radicands. The reason why you can do this is because root x and root y have the same index. Okay, they have an invisible index here of 2. So the square root has an index of 2, but you don't normally write it down. Alright, so in order for you to be able to multiply radicands, their indices must be identical. Okay, so when you multiply coefficients and radicands, the last step is you can just simplify after that. Alrighty, so that's the formula that we're going to be using to multiply radicals in this presentation. Alright, let's take a look at the first example. So what if you are supposed to carry out the following multiplication? Let's say you're to multiply the following. Question 1, let's say you're multiplying the square root of 5 by the quantity 3 plus 2 root 6. Okay, so how do we multiply a situation like this? Alright, so the square root of 5 times 3 plus 2 root 6. Now in order to do this, you just have you have a coefficient on the outside, right? So this irrational number we have here has an integer and a rational component. So what we're going to do is we're going to distribute. Alright, root 5 times 3 and then root 5 times 2 root 6. So that's going to give us 3 root 5. So 3 times root 5 is just simply 3 root 5, end of story. In this case right here, we're going to have 2. There's a 1. Imagine that there's a 1 right here, okay, as a coefficient. What is 1 times 2? It's 2, right? So it's 2. And then what do you do with the radicals? If you remember what we talked about in the formula, if the indices are the same, you multiply the radicands. So it's 5 times 6. Alrighty, and then that reduces to 3 root 5. Now we're in the simplify step. Alright, 3 root 5 plus 2 root 6, root 30, sorry, 3 root 30. When you're done, inspect your radicals to make sure that they cannot be simplified any further. So root 5 is prime, you can break this down. How about 30? Let's test that out to see if 30 can be broken down. We're going to use our factor tree to look for any factor that repeats. Let's use prime factors. 2 goes into 30, 15. 3 goes into 15, 5. None of these repeats, so there are no perfect squares that can be factored out. What does that mean? Ladies and gentlemen, this is our final answer. 3 root 5 plus 2 root 30. Okay, let's take a look at another example, question number 2. Let's say you were to multiply root 5 by root 10 plus root 2. Okay, let's do this one. So how do we do this? Let's rewrite the problem. We have root 5 multiplied by root 10 plus root 2. So we're going to distribute again, okay? So we're going to distribute root 5 to root 10 and then root 5 to root 2. These are just radicals with identical indices, so we're just going to be multiplying the radicands. What does that give us? We're going to have the square root of 5 times 10 plus the square root of 5 times 2. Let's simplify that. So 5 times 10 is 50. So we have the square root of 50 plus the square root of 10. All right, let's go ahead and simplify. Root 50, let's see if we can break that down. Looks like we can simplify that. So we have root 50, we're going to break it down completely, okay? So it ends in a 0. Any number that ends in 0 or 5, 5 goes into it. So 5 goes into 50 10 times. And then same 5 goes into 10 twice. Ladies and gentlemen, we have a perfect square, 5 and 5. What is the square root of 5 times 5? The square root of 5 times 5 is 5, so this product comes out of the radical as 5. Okay? All right, so our simplified form for root 50 is going to be 5 root 2. How about root 10? If we break down root 10, it's just going to be 5 times 2 as we have here, and no factor repeats, hence it cannot be reduced. So we just replace root 50 by its simplified form, 5 root 2 plus root 10, and there you have it. All right, moving right along. Let's take a look at question number 3. So for question 3, what if you have to simplify root 2 times 5 root 6 plus root 2? Okay, let's go ahead and do this. We're going to be multiplying root 2 by 5 root 6 plus root 2. So what we're going to do here, ladies and gentlemen, is as follows. We're going to distribute. All right, distribute. Imagine as though you have a coefficient here, the invisible coefficient, which is 1. Bam. All right, so when we distribute here, what we're going to have is 1 times 5. All right, so when we do the first distribution, 1 times 5 is just 5, times the square root of, now you multiply the radicands, 2 times 6. Okay, plus root 2 times root 2 is just going to be the square root of 2 times 2. Let's simplify this. So we're going to have 5 root 12 plus the square root of 4. Okay, let's simplify. Oh, we know what the square root of 4 is. That's easy. The square root of 4 is just 2. How about root 12? Let's break that down. So to simplify root 12, let's break it down into prime factors. 2 goes into 12 because it's even. 2 goes into 12, 6. 2 goes into 6 3 times. Ladies and gentlemen, we can simplify because we have a perfect square. 2 times 2 is 4. That's a perfect square. What is the square root of 2 times 2? The square root of 2 times 2, or the square root of 4, is just 2. So the simplified form of root 12 is 2 because of the 2 times 2. And then this 3 stays behind because it's not a perfect square. 2 root 3. All right, let's go ahead and reinsert that right here. So we're going to, now don't forget there was a 5 out there before. So it's going to bring down the 5 and then the 2 that came out, root 3. All right, simplify a little bit more. 5 times 2 is 10. 10 root 3 plus 2. And ladies and gentlemen, that's the final answer for question number 3. All right, let's take a look at one more problem, and then we will have you do some practice problems to demonstrate that you've mastered this standard. Okay, so let's say we have 5 root 10 times negative 4 root 2 plus root 5. Okay, so let's multiply this one. We're going to follow the same procedure that we have been using for the previous problems. Coefficient goes with coefficient, radicands go with radicands when we are distributing. Okay, so let's go ahead and do that right now. So this 5 root 10 as a whole will get distributed to this term right here, and it will get distributed to that term out there also. Okay, so what would that yield? We're going to have, let me show you the intermediate step. We're going to have 5 times negative 4. That's the coefficient. And then root, multiply the radicands. 10 times 2. Plus, now there's a 1 here, the invisible coefficient. We have 5 times 1, which is just 5, times the square root of 5 times 10. Well, let's switch the order. The square root of 10 times 5. It doesn't matter, multiplication commutes, so you also get the same answer. If we simplify this, we're going to have root negative 20 times the square root of 20 plus 5 times the square root of 50. Now we're going to go ahead and simplify root 20 and root 50, see what we get. All right, so let's start with root 20. So root 20, are there any perfect squares that can be taken out of this radicand? Let's break it down. 2 goes into 20 10 times. 2 goes into 10 5. Ladies and gentlemen, we have a perfect square, namely 2 times 2. Okay, so 2 times 2 comes out as a 2, and the 5 stays behind. Root 20 simplifies into 2 root 5. How about root 50? Let's break it down. 5 goes into 50 because it ends in a 0 or 5 10 times. 5 goes into 10 twice. We have a perfect square as a factor of 50, namely 5 times 5 or 25. Okay, so that comes out as, it's going to come out as a 5. Okay. All right, so the simplified form for root 50 is the square root of 5 times 5, which is 5, multiplied by this 2. That is not a perfect square, so that 2 stays behind in the radicand position. So we have 5 root 2. Okay. All right, so let's insert the simplified forms back. We're now going to have negative 20. Now root 20 was simplified into 2 root 5, so don't forget what you had there before, okay? Plus 5, and then root 50 simplified into 5 root 2. If you simplify this, just multiply the coefficients. You have negative 40 root 5 plus 25 root 2. And there goes the answer to question number 4. All right, it's now your turn to do some practice problems. Alrighty, so what we'd like you to do, we'd like you to try out these 5 problems. We'd like you to simplify the following, follow the same procedure that we went over in the presentation. So go ahead and pause this video at this time and then try out these 5 problems. When you're done, click on the play button and we will reveal what the correct answers are. All right, welcome back. Hopefully you had a chance to try these problems. Let's take a look at what the answers are. First one is 5 root 2 plus root 10. And then for number 2 is 2 root 3 plus 6. For number 7, number 3 is 15 root 2 plus root 30. And then for number 4, it's 24 root 10 minus 20 root 6. And then for number 5, it's negative 12 root 2 minus 20 root 3. All right, ladies and gentlemen, how well did you do on these 5 practice problems? Let us know in the comment section below what you scored. If there are any questions or comments or clarification that you would like on these practice problems or the problems we did in the presentation, just include that in the comment section and we will be glad to assist you. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of radicals, to give us a thumbs up or a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other math tutorials. We upload math videos to our page on a regular basis. As indicated earlier, if you have any questions or comments, just include it in the comment section below and we'll be more than glad to respond. Don't forget to visit our website at mathgotserved.com for tons of resources to help you master algebra. Thanks again for watching and have a wonderful day. Goodbye.